welcome to this demonstration of intelligent orchestration for autonomous mobile private networks. This demonstration is brought to you by Arctos FNT Inmanta. My name is Mats Eriksson and I will guide you through this demonstration. So, mobile private networks is a substantial business opportunity as outlined by many analysts, but it is of a long tail nature. And that means that there is a huge amount of product variants to meet each and every customer, and some of them are sold only once or twice. And this calls for autonomous networks. These sales instances needs to be very autonomous and cannot be managed like a pet. So if we look at that and how from a communication service provider, we have both the public central cloud, the network edge and on-premises edge to make use of. So the first requirement we would need to fulfill is the efficiency and easiness to deliver these services. That means we need to dynamically adapt to business requirements. We need a strong abstraction, modeling and policy and optimization concepts to make it easy to tailor and achieve this long tail nature of this business. We need to be able to mix the network edge slicing and dedicated on-prem deployments, or for that matter, dedicated deployments in the network edge or in the cloud. We need the scalability and it to be autonomous, meaning we need the full automation across the life cycle. We need a single source of truth from which we can build this automation, and we need concepts to reuse service models, easily build up new tailored services. And of course we need the flexibility and openness, end-to-end, multi-domain, and we need it to be vendor agnostic so we can make use of partnerships and ecosystems and fit these services into the wider context of an enterprise. So introducing the demonstration and the orchestration solution, we have three parts. The first and important part is the orchestrator that comes from Inmanta. We have onboarded an MPN service model onto the orchestrator. That service model makes use of policies provided by Arctos Labs, and those policies are two types. There are policy rules that uses open policy agent capabilities, and there are optimization policies that uses minisync capabilities in the Echo platform. And then we also have a service and infrastructure data provided by FNT. We have GUIs, so we can observe what is happening in the demo. The demo is around selection of UPFs for slices based on policy rules and cost optimization. It includes migration of slices between the UPFs, configuration of these slices, and updating of the inventory. The network that we're using for the demo has two locations. One central public cloud where we have a UPF and the core network control plane, and an on-premise edge, for example like an airport, where we have another UPF already deployed. These core network components comes from Autonet, and as a note, we're selecting UPFs, and this is just because we want to reduce time for the demo. Could have equally well been an on-demand deployment of dedicated UPFs or something similar to that. So the first slice we have is an eMBB slice. This slice doesn't have any policies on constraints of which UPF to use, so we're just applying a cost optimization policy for this slice, which means that it will end up using the on-premise edge because that's available and can't be used for many other things. So that's the most cost optimal solution for this first eMBB slice. And then we're automating that orchestration and having that updated into the inventory. The second slice that will come about is what we call a trusted slice. So this also illustrates the concept of creating your own slice types by adding policy rules. So in this case, we have a policy that says that this UPF have to be in a trusted location, for example, an ENISA compliant cloud, and this happened to be the central public cloud. So we need to select the UPF1 here for that slice, and then we're applying cost optimization. So had we have other clouds to select from, we would have selected the most cost optimal one. Then we're migrating the eMBB slice because we want to deploy an isolated slice. This is another new type defined. This means that we have a policy rules that this UPF cannot be shared, and traffic needs to stay local. So it needs to use this UPF, but that UPF was already occupied by the eMBB slice. So we need to move that slice to the central UPF, and that's the scenario of the demonstration. Note that these kind of mechanisms apply for assurance and failure situations. If something failed, we would be able to derive how to mitigate those things, thereby creating the autonomous network capability. So let's start the demo. What you see here is the Inmanta orchestrated dashboard, their GUI, and we can deep dive into information here. The starting point of this demo is that we have already two slices being deployed, meaning the eMBB slice, which is slice 1 in this case, and the trusted slice, which is slice 128. They are being deployed on the central side and edge side respectively. So that's our starting point. We can see that also in the FNT inventory and how these two slices are using inventory resources, infrastructure resources. We can also go into our core network, which comes from Ethernet. We can see that we have two slice instances being deployed. So that's consistent with our inventory view. And if we drill down a bit into the information that we have about these two slices, we can see that we have slice instance 0 and 1, which is the type 1 and 128. And then we can go and add a slice. So let's do that, which means we're ordering a service slice type 129 with an instance differentiator 01. And then we're confirming this. This basically means that we're starting the orchestration process. And this means that we're invoking the policy engine with some questions, basically sending off the data of the two slices that we have and how they are being deployed, which is on two different UPFs and a blank UPF, because this is the new slice, so it's blank. The properties, meaning the outcome of the rules of the OPA part, is that for slice type 1 it requires a separate UPF, false, meaning it can share UPFs. So candidates here are UPF2 and UPF1. Slice type 121 also doesn't have a requirement on a separate UPF, but it has a requirement on that the location of the UPF needs to be the secure one, meaning it's only UPF1 that complies with that. And the new slice has to have a separate UPF, meaning it can only run on UPF2. And then we're applying cost optimization onto this information, and then the output of the complete policy query is that slice type 1 should be deployed on UPF1, slice type 128 should be also on UPF1, and the new slice 129 needs to be on UPF2. So that's what's returned into the orchestrator. So now the orchestration process starts, and we can follow this, and all the configuration data is being prepared into a candidate configuration, and still this is not concluded, so the selected UPF for slice instance number 2 is not ready yet, but soon it will, and then you will see it. So now what happened was that we have a candidate configuration with UPF 2 being allocated to slice instance number 2, and you also saw that for slice instance 0 the selected UPF changed. We can now push this candidate information into being the active configuration, and now you see that we have for slice type 129 we have that on UPF2, and the other 2 slices we have on UPF1. We can also go into the inventory and see the consequent mapping of the slice instances to UPFs and to the infrastructure. And then onwards we can also go into the AutoNet and update that into that dashboard, and you see now that we have 3 network slice instances up and running. So that concludes the demo, and you saw in the demo how the 3 different components being the orchestrator from Inmanta, the policy engine from Arctos Labs, as well as the inventory. So this concludes the demo, and we would of course very much like to talk with you about other MPN projects that you may have. So please reach out to Ristina Paparitsova at Inmanta, Daria Batrakova at FNT, or me, Mats Eriksson at Arctos Labs, or read more on our white papers on our webpage. Looking forward to talking to you